So we've introduced the concept of functions already. We've talked about how you define them and you have to provide like an output type, such as an int or a string. And if it's not returning anything, there's the type of a void, for instance. So we've done sort of the basics with functions and how they work. And what we're going to do is try to expand what we can do when we create functions, and also look at so just some more concepts related to a function. So in programming, functions are really the name of the game. A key to good design in computer programming is to separate ideas, separate different tasks into sort of isolated sections. And by having them be separate, that makes it easier to maintain and update programs. It also makes it easier if you have like a team of people to kind of divide up the work in different ways. So functions are fundamental to the design of good programs. The other thing that they are helpful for is you don't have to go back and rewrite code over and over again for a solved problem. If you want to have just a simple like greeting and instructions that you're going to print to the user every time, you could very easily just create a simple function that outputs some text and just does that and moves on. When we've used libraries before, those are known problems. They're very common kinds of things that people want to do, that we're not like reinventing the wheel. The stuff with the IO stream, for instance, getting inputs from a keyboard, doing outputs of text, the C in and C out, having to design all the gory details of that stuff ourselves would not be fun, let's just say. So they let you tackle known problems that people have already worked long and hard at to come up with how to do that. So what we're going to do is we're going to look at what can we do where you've got functions that have different parameters. What would we do if functions do similar kinds of things? Like if we ask for a name, do they only want the first name? Do they want the first and last together? And so we've seen distinctions, like if you're opening a file where you can have a function with multiple parameters. So you could just do like a dot open where you give the name of the file. You might do a open function where you give the name of the file and then tell it that you're going to apply that to the file stream. So you can have functions where they only have one parameter. You can have functions that have multiple parameters. This is kind of what those two are getting at. One where you just call the name of a file, the other where you call it and then tell it to do something with us. So something we might do, for instance, we could have a massive string where we got the text of an entire book. Maybe we want to change one word from this book into another book. Looking at you, Huck Finn, that word is not cool. You know the one that I mean. So what you could do is you could define a function where you're going to look for a particular string, look for a particular piece of text, and then, you probably, Microsoft Word has a function that does this exact same thing, where it'll find instances of a particular string and you can tell it to replace it with a completely different string. So that's something that we could do. We're going to talk about, we're not going to get into the gory details of that exact function, but we'll talk about sort of conceptually how we would do that. So when we define a function, how is it we would define a function? We need a header and we need a body. And then once we have a header and a body, we can then call the function. So for instance, you can make a function that will average 3 numbers. So we're going to look at this first program here. this thing get out of the way. All right, so and actually let's move this like all the way over here. All right. So what do we got? So for our first one, we're gonna include the IO stream and use the namespace like we normally do. We're making ourselves a function. It is going to output a float. We're gonna call this function average. This is going to take 3 parameters. Each of them will also be floats. We'll just call them float A, float B, and float C. And then what we want this function to return is A plus B plus C, and then I'll divide that by 3.0. And when we then call this function, we're in the program, we're gonna output some text, so the average of 3, 7, and 10. We're gonna do average 3, 7, 10. And we run this and it'll give us some number, which is 6.6 repeating, I think. If I remember right. Yeah, 6.6 repeating is what that is. And so anyway, here we've got a function it's taking 3 inputs, and we've seen this before. You define the type of output, you give it a name, you put in the parentheses all your different parameters, use commas to separate them, declare what each kind they are, and then these braces, you put what the actual body of the function is right there. This is a very short function, but a function is always going to return. The return command is the end of the function. Anything under the return command is actually going to be ignored. So this will return, and then you've got this mathematical formula telling it what it's returning. So anyway, there is that function right there. So maybe we want to modify this function and do just 2 numbers, or maybe we want a function that can handle 4 numbers. So one option is we can make different functions that all have the same name and basically have a separate function for each situation. And there's actually a term for this. This is called overloading a function. And what we're doing is we're taking average and we are overloading it. It's the same name each time, but there's multiple functions that all have that name. And so the compiler, when we call it, is going to try to sort of figure out which one we're going to talk about. So like here, we've got an average function that only has 2, and so it divides by 2. Here we have one for 3. Here we have another one for 4. It divides by 4. And then here we're calling each of these functions here. We're out averaging 3 and 10, 3, 7, and 10, 3, 7, 18, and 10. We're just averaging different amounts of numbers. And so we've overloaded the name average, the function average, and there are 3 distinct functions that all do essentially the same thing. And this gives you an idea of why you would maybe logically want to have an overloaded function, because you're doing effectively the same thing, just with different amounts of data. So what's happening in the background here, the compiler is going to call the correct function based on the number of parameters. The function's overloaded because it does, make sense to use the same name. We are finding the average each time, just depending on how many values there are. You don't want to be in the habit of overloading with functions that do very different kinds of things. Don't just do it just because. You would want a compelling reason to do so. So in the computer's mind, if you will, here's sort of what's happening. What the function's header it creates a signature. And the signature is a reference to how many parameters it has and what kind of parameters go into it. And so based on the number and type of parameters, that will give a distinct signature to different function names. And so even if it's the same name, it can have the same name but a different signature, which is sort of in background how the compiler tells the difference. So when the function's called, the compiler matches it to the corresponding signature. It doesn't just match the name, it matches the number and kind of parameters. We kind of talked about this. So all three of these functions, even though they're all called average, they each have a distinct signature, which is how the compiler is able to tell them apart. The signature actually does not include the return type. So you wouldn't want to make like an average function that returns an int and then a different average function that returns a float, only to do it with like the same number of values, for instance. Like having float average for two numbers along with int average for two numbers, that's not going to work because it doesn't actually care about the return type of the function. It only is related to the parameters. Let's see. So we can't have an overloaded function where they return different types, such as an int and a float. I basically just said that. So you can convert to one variable to another when you call a function. And if you call a function where the parameters don't match, they can be converted into things that do. So you could, for instance, if it's expecting floats and you give it ints, you can convert them to floats. But if it can be converted easily, that will happen automatically. That's only possible when you match one distinct signature. That's the catch.